So this question, we have a 6 kilogram particle moving to the right at 4 meters per second as shown. We want to know what's the magnitude of the angular momentum about point O. O is down here. So we want to know what the angular momentum is. Well, I know that the angular momentum, one of the forms that I can get for angular momentum is I omega. The other one that I can get is R cross P. It's a relationship between the linear momentum and the radius that it's out. And it is a cross product. So I look at this object. I don't know what its angular velocity is. They give me a regular velocity v. They don't give me an angular velocity. So I think I want to use this second equation. So L is equal to R cross P, which, if I actually just want the magnitude of this, it's RP and the sine of the angle from R to P. The vectors R to P have direction. I want to know what the angle is between those. So let's draw what R looks like. R is a vector that's in that direction. P is going to be a vector in this direction, because I know that P is equal to mv. So this equation can be rewritten as, well, I guess I labeled it a big R, mv sine of theta. All right, so what do I have? Well, I have, move up a little bit. I have that a radius, a mass, a velocity. This is pretty easy. I have a radius of 12 meters. I have a mass of 6 kilograms. I have a velocity of 4 meters per second. And I need to know the sine of my angle. And my angle that I'm going to get is going to be R into P. So I can actually use this little angle that's 30 degrees. Normally, I would actually use the large angle, which is 150 degrees, but I know that the sine of 30 degrees and the sine of 150 degrees are the same thing. So they did give me the right angle. I always want to check the angle to make sure it's a mutual angle between the vectors. So this is going to be 12 times 6 times 4 times 30. Sine of 30. Sine of 30 is 1/2. So I get, 6 times 6 is 36 times 4. That's going to be kilogram meter squared per seconds. That's the right units, which 36 times 4 is going to be 4, carry my 2, 144 kilogram meter squared per second. So I get answer choice C being the right